duality of matter. Let's talk about matter before we talk about duality. Matter. A lot of things you have to understand about matter. When we are talking about matter, we know that matter is anything that has weight or mass and occupies space. Matter is anything that has weight or mass and occupies space. That's basic definition. And when you are talking about matter, you talk about three states of matter: solid, liquid, and gas. That's another thing. When you are talking about matter, in solid is compressible, and liquid is so, and gas. But when you are now talking about behaviors of matter, it is actually different thing. So when you are talking about behaviors of matter, you could talk about matter could behave like in two ways, like in waves. Matter could behave like in waves, or matter could behave like a particles. What we are now saying is that matter can behave in two ways. Matter can behave like a waves, or matter can behave like a particles. When matter behaves like a waves, it has the properties of a wave. And when matter behaves like a particles, it has the properties of a particles. So let's talk about properties of waves. It is not new to you. In physics, we have talked about many properties under wave. We have actually we've talked about reflection, refraction, diffraction, polarization, interference. But when matter behaves like a particles, what do we talk about? We have talked about diffusion. We have talked about osmosis. We have talked about crystal structures. We have talked about photoelectricity. We have talked about Brownian motion. That is when matter behaves like a particles. But when you are talking about the Broglie wavelength, it is usually used to discuss about matter. What do we talk about when we are talking about the Broglie wavelength? We said the Broglie wavelength equals to Planck constant all over momentum. That's the formula of the Broglie wavelength. The Broglie is a scientist. He's actually given us this formula where momentum equals to mv, mass of electron and velocity of light. So when you now have the Broglie wavelength, you have it to be H equals to mv. You know, he said kinetic energy can be equals to EV. He said electronic charge and stopping potential or potential difference, stopping potential anywhere. So we also say kinetic energy in a layman understanding. He says kinetic energy equals to 1/2 mv squared. So if we now say kinetic energy equals to EV and kinetic energy equals to 1/2 mv squared. So that means what we are saying is that by mathematics we say kinetic energy equals to Ke equals to Ke. That means we are actually talking about the same thing. So that means we are talking about EVS equals to 1/2 mv squared. If you solve further, you have 2EV equals to mv squared. So from there, what are you going to have? You multiply the both side by mass. You have m.2 EV equals to mv squared. You multiply this side too by mass plus n. So we multiply the both side by mass in order to reduce the velocity. That is what we mean by electron diffractions. Is the process of reducing the mass and increasing the mass and reducing the velocity. How do we reduce velocity now? You know that velocity is square here. In order to reduce it, we have 2m EV equals to m squared v squared. So from there, what are we going to have? We are going to have 2m EV equals to mv all squared. So from there, what are we going to have? This is momentum. Do you know that? So that means we have p squared equals to 2m EV. we mentioned that NV equals to P. So now we cannot conclude now by saying P equals to square root of 2m EV. So let's come and substitute here back. So if you substitute, so that means we can now say that H equals to square root of 2m EV. So that is the Liebrow-Gelly wavelength. But is that all about duality of matter? No. We actually talk about Heisenberg principle. What does Heisenberg say about duality of matter? Heisenberg mentioned a lot of things. What does he mention? Let's mention a little things about what Heisenberg says. Heisenberg principle. It actually mentions that both uncertainty in position, and uncertainty in momentum cannot be both determined at the same time or simultaneously. He said both uncertainty in position and uncertainty in momentum cannot be determined at the same time. But is that all? No. When we are talking about in terms of energy, he said both uncertainty in energy and uncertainty in time cannot be both determined at the same time or simultaneously. So, we have actually discussed about duality of matter. We say that matter can behave in two ways. Matter could behave like a wave or it behaves like a particle. If we are talking about matter to behave like a wave, it has the properties of a wave. And when matter behaves like a particle, it has the properties of a particle. What are the properties of a wave? We have actually mentioned there. Refraction, diffraction, polarization, interference. That is for waves. But when we are talking about particles, we talk about dilution, we talk about osmosis, we talk about crystal structure, we talk about photoelectricity or photoelectric effect. Thank you very much.